Blake Caldwell, ladies and gentlemen, from Oak Ridge National Laboratory is going to talk about best practices in system administration of Lustre. Blake, take it away.
Hey everyone, so I'm Blake Caldwell from National Center for Computational Sciences, part of Oak Ridge National Laboratory. So here at the very end of LUG, I'm going to try to talk about best practices for scalable administration of Lustre. And so rather than spend the next 3 days, which this could take, I'll just try to cover in 20 minutes some of our contributions to the topic, some of the things we've learned from experience. So to start off, what's different at scale? Well, pretty general things. We expect that there's going to be more nodes, more components, so that just means there's more things to fail. So we need to have tools that have ways of dealing with these. So we need to design redundancy into the system, just practice good design, taking into account performance considerations. We'll do some fine tuning. Some pretty basic stuff. Something that's also really important is testing. It's hard to do an identical hardware. I mean, we don't have a spare Jaguar lying around, so we can't do identical testing, but we can try to duplicate it on a smaller scale and do what we can. So what's more complicated is that there's a scale out over time, that we're adding new file systems, we're splitting up file systems. Sarp talked about it earlier, that we split up Widow or Spider into 4 different file systems for metadata performance issues. So now these 4 file systems have different configurations. That just made that's more work for us. So we need ways of dealing with that, being clever about how we combine configurations and just limit where the changes actually are. So right now we have 11 production file systems. This seems to be this number keeps growing. That's 272 Lustre servers. 198 of those are from the original Spider file system. There's also different InfiniBand fabrics. We have 5 separate fabrics we have to manage with over 1,400 HCAs, different hardware vendors, different technology generations, different distributions for each of those. Well, not each of those, but several different distributions. So kind of what I'm going to center everything around in this talk is this, being consistent. It's really what makes our job possible. Makes it possible to manage all these different file systems. So it would be nice if we could just use a single operating system image to manage everything, all of our file systems. Well, that's not even close to possible. There's different reasons we have to separate the file systems for. Might be a different infrastructure, just might be different requirements, different uptime requirements. So we just have to choose the tools that are available, that are out there to try to make it possible. Luckily, this is cluster administration. It's and there's a lot of people that are doing it. There's a lot of good tools out there to help us do this job. So best practice number 1, we use diskless imaging for our nodes. So from one management server running with the JEDI system, the generic diskless installer, we push out more or less, an identical node to a file system, to all the OSSs, to the MDSs, and JEDI handles some configuration on that end. But one big benefit this provides us is that we can go to the management server, shoot into the image, and run something like a yum update during downtime. So right then we upgraded the kernel version, and we probably put in some exclusions as well, but we've done a lot there. We might upgrade 7 file systems with just 1 command. So when we're done with the outage window, we can boot up the systems and they're all up to date. So, and this also because they're diskless, there's not a lot of worry. If we have a problem, we can just reboot the node, powerman-r, and we know that in a few minutes we'll be back up with a node starting from a clean slate. So 7 of our file systems run from 1 image. The rest are kind of fragmented into running their own image or sharing smaller sets. So another piece that's essential to this is a configuration management utility. We use both CF Engine and bconfig too. Puppet could also be used to do this. It's really convenient to be able to specify in a hierarchical nature what host we want a configuration change to be applied to. Say we want to make a change to implement a new monitoring check on just our OSSs. So we might edit the snp.local.conf file for just OSS nodes on the Widow 2 or a Widow file system. So we can specify all that, let the configuration management tool run, do its magic. It will take care of rebooting SNMPD or restarting SNMPD for us, and we're continuing on with no service interruption. So this is actually another huge area, monitoring and alerting. It's really what we rely on with so many different components out there that could fail, different failure modes for these components. We need a system that will just go out there, look for the problems, and try to alert us as soon as possible. Hopefully get to us before the users. That's really hard to do, but we try to do the best we can, try to do the best we can, and improve on that later. So we use a combination of Nagios, Splunk, Sec. We've used Sec before, and we're starting to implement more Splunk searches and trying to emulate some of that functionality in Splunk. We've had to customize Nagios a lot because we rely on it significantly to manage or to do most of our checking for us. So we'll do things like checking RAID controllers. We use Dell Open Manage for our nodes like hardware status and environmental statistics. We also use Nagios to monitor Lustre health in /proc. Things like make sure all the OSCs are mounted, that also the LNet queue depth isn't increasing. And we also are starting to use it for our network fabric. I'm going to touch on that in a second. So this is just something that's just worth mentioning along with notifications is that it's useful if your notifications can tell you a little bit more than just something's wrong. That can tell you what node it's on, what the problem is, and so it's giving you a head start. Like as soon as you get that notification, that you already have an idea what the problem is. So I mean, we get a lot of times Lustre health check will go critical, and I mean that's a really broad a check. We don't really know what to do with that, so it requires us to go in there and poke around to find the answer. But so hopefully we can design checks that, based off past experiences, that will alert us to the situation, alert us to the exact situation that happened for that instance, and maybe we can design a check that will tell us about that specifically next time. And so just look at where these problems slip past the users, and then slip past the notification system, and the users were the first ones to get to you. Then that's just an opportunity to go back, see if you can write a check that will have Nagios, for example, alert you before the users do. So this one, just monitoring your storage interconnect fabric. We use an InfiniBand fabric for our systems, and we found that it can have a big impact on Lustre. Any like marginally functioning component or just degrading performance on a link can really propagate up the system, cause serious problems. I mean, not just take down a node to the point where users are noticing this problem, and it can just be as simple as a bad cable. Oftentimes it's not any big problem, but sometimes they're just hard to detect. So this is an area that we're trying to improve our monitoring on. We want to have a better handle on when these things are coming up, and so we're not just alerted when an IV link goes down, but we see the symbol error counters increasing as an indication that the link's going bad, and then we can catch it before it negotiates to a link speed of 1 or link width of 1 or lower link speed. So you got to monitor IV switches, or just like you would other network hardware. Sometimes we had to write our own Nagios checks for some of them. It's also useful if you can do some kind of topology mapping, so you can verify what your fabric looks like with what you expect it to look like. As it grows over time, you're going to be adding partitions, cable changes, maintenance. There's just going to be things that are going to crop up that you're not going to expect. So this is just kind of a useful sanity check. It's something that's on our wish list. We're working on it, and it'd be nice to have. Another best practice that was just talked about a little bit is the importance of event correlation. Lustre is nice in how much information it gives you in the logs. it can be difficult even staring at the most relevant messages to figure out actually what's going on, let alone if you, say you're troubleshooting a mount failure. Well, you look in the logs, you have the MDT mount, you have some OST mounts, and then you have another file system that comes along and evicts a client. So you might have 100 messages interspersed between there. I mean, that's just a simple example. You might be looking at Lustre log over a period of an hour. So it's really useful if you have an automated system that can kind of go in, pull out the relevant messages from the relevant nodes from that file system, and kind of give you some more useful information. So those are some alerts we've used Splunk to write to just send out an automated alert when we see those events happening in the syslog. We'll get an email from Splunk alerting us to that. So this is a screenshot of our Splunk system here. So as you can tell, it's not a simple search. Splunk gives you a lot of flexibility, and it's also a problem that it can take a lot of time to develop these searches. But it gives you the flexibility to group messages by, in this case, we're grouping it by like the file system name, or under there the cluster. So these are all for the widow file system. But it also lets you pull out fields like the NID field here. So rather than looking inside the Lustre message, you can pull that out, put it in its own column. You could even group transactions by that NID field. So you might be only interested in all the messages pertaining to that particular NID. This gives you an easy way of pulling that information out. Another useful piece is that it gives you a timeline just over your search duration, so you can see like the event counts, like how many, if you're looking for eviction messages, how many clients were evicted just over time. So along with some of this monitoring is that, well, separate from the monitoring, but another best practice, when there's a problem, and sometimes the fastest solution isn't to actually go in, poke around to try to find the root cause. Sometimes it's nice if you can just, with confidence, reboot the node and get back to a clean slate as quickly as possible. I mean, we all like to go in, dig around, and find the root cause, but having a procedure where you go through and define all the diagnostic information that you want to collect, such as, from LCTL, DK, some timeouts also. You can collect all those, and then we use kdump, so we can trigger a crash dump, and then that node will immediately take that crash dump and send it back to the management server for processing later. It takes a while, but it will eventually. It's a big file, so it can increase like the time you're waiting for it to reboot. But send it back there, and you can use that information later. You don't have to deal with that now. You can just focus on getting the node back into production as quickly as possible. With kdump, it'll reboot automatically, but you could also power man it. So additionally, we use conman to do IPMI console logging, so that from our management server, we're constantly monitoring the console logs of all the nodes. That lets us just kind of let that go in the background, and if there's a problem, we can go back to our console logs and check those out later. So best practice number 6 is to have a little bit of workload characterization. So as a Lustre sysadmin, and you see that there's a problem with the file system, or a user complains DF is hanging. Well, you don't know if that's just because the system's loaded. You don't know the actual root cause. So having a resource to be able to go to quickly to get a little insight into what's going on the compute resource is really helpful. We're lucky enough to have some scripts that generate what we call MDS trace reports for us, and this correlates information from the CRAEX case, from the AppStat, basically telling us which jobs are running, how large the jobs are, and also what RPCs those jobs are issuing. So right there, we can use that information to just give some insight quickly into what's going on, whether it's a normal slowdown or if it's a slowdown because of a Lustre problem. So best practice number 7 is really just well, if there are holes left in this, if there's pieces that are going past your monitoring infrastructure, things that need to be done that users want that you can't provide quickly, well, sometimes writing your own tools is the best solution. So we've done a few interesting ones. We co-developed some scripts to help implement a purge policy for our file systems with Nick Cardo at NERSC. So this any2 scan, gen hit, and purge has been useful for quickly going through our file systems, and looking for the files to purge. We also have some software that's really neat, Lustre DU, which allows users to query a database for their usage information by the username or the project, so that they can query that information quickly rather than going out and fetching the data from metadata, in which case they may be sitting there waiting for, well, who knows how long, if they ever get a response back. So also we wrote a tool called DDN, we call it DDN tool, but it pulls the DDN 9900 enclosures for performance and environmental statistics for graphing and just some later analysis, and we collect that all in a database. So that's really, that's all. Those are the main things that I want to contribute from our experience, that things we've noticed that we've had problems with that we think would be useful, or that we think have been useful, and we hope that they're useful ideas for you guys or useful tools. So just to recap, consistency is the most important thing. Having a consistent operating system image and a consistent configuration and consistent interfaces for tools that you use just makes it possible to keep scaling out, so you have more and more different file systems. And so also here, just for if you want to download slides later afterwards, some links to some resources or some tools that we use. There's a paper on some of our describing some of our tools, Lustre DU. Python RDMA is an interesting project we're looking at trying to use more for InfiniBand monitoring. That's just something on the to-do list. And Splunk, I showed you that. Also, Lawrence Livermore has a lot of good utilities for cluster management. We use PowerMan, ConMan, PDish, genders as well to group nodes or to provide classifications for nodes. So you can combine that with PDish. And then, of course, JEDI, which is really kind of the core of this diskless imaging system that we're using. So that's it for me. Are there any questions?
Do y'all run a single Nagios image, or do you run multiple Nagios? And do you partition your cluster and target different portions of it with different Nagios instances?
So there's another group that monitors or that handles the Nagios infrastructure. I can't tell you right now if it's one or if we have to use a cluster, but it is a huge load on it. When we started doing this, we were running checks every second, and it was too much for our initial Nagios deployment. So yeah, we had to make upgrades to the infrastructure. I don't know the exact status of how it's deployed right now.
You said that Lustre DU uses a database. How do you get the data from the database?
That's an interesting process. So it uses some data from any2 scan, and I don't know if Jason, if I could ask you to explain a little more detail of that.
So with any2 scan, you get the OST ID and object on that OST in a field, because basically you're taking a full dump of the metadata target. So then we send the object, we have a mapping from FS Lustre that shows you what OSS is on, or what OST is on each OSS. Then we send to a custom daemon that is written the object ID, and the daemon returns the size on disk. Then we aggregate that and stick it in a database.
You do this on our live running system?
Yes, we do it every day.
Not currently. I mean, so any 2 scan, you'd have to talk with Nick Cardo about that. So, yeah, no, it's not publicly available right now. Yeah, there's a process that we could go through to try to share some of that information.
All right, ladies and gentlemen, Blake Caldwell. Thanks, Blake.
Thanks.